All right, so you're factoring each of these, picking up on the stuff that we did before. These are actually somewhat simpler versions of a lot of what you're doing at the end of the last unit. And for some of us, that throws us off because, like, wait, it's just got a plain old x in it. What am I supposed to do? Well, remember that the first type of factoring that we saw was where we divide each term by the same thing. So if I take a look at that first one, the 12x and the 16, what can I divide both 12 and 16 by? There's two options. There's 2 and there's 4. I want to use the biggest one, so I'm going to use the 4. And so if I'm going to divide by 4, that means I write the 4 out front of the parentheses, and then I do the division. Because, of course, this is distributive property backwards. So 12x divided by 4 is 3x, and then 16 divided by 4 is 4. That's it. We're done. It's factored. Right now, for the rest of them, same basic process. So for the second one, the 20 and the 35, I can pull a 5 out of both of those. And so that's going to leave me with 4 minus 7x. The next one, 18x, 15y. They both have variables, but it's not the same variable, so I can't pull out the x or the y. I can just look at the 18 and the 15, out of which I can pull a 3. And so then that's going to give me 6x minus 5y. All right. 50a plus 40b. Notice they both end in zeros, so I can pull out a 10. And then a and b, again, they're different variables, so I can't pull out either of those. So I'm going to get a 5a plus a 4b. And then for that last one, 21 and 70, I can divide both of those by 7. The n and the d, I can't divide out that because it's not the same in both. And so then I end up with 3n plus 10d. And we're done. That's the factored form for each of those. All right, so the reason why I had you start with that factoring is it actually leads us into our topic for today, which is simplifying and reducing fractions. So go ahead and write down this problem. And you'll find that reducing a fraction is actually the same thing as factoring in many ways. Because remember, when we were factoring, we just did a problem that said 21n plus 70d. And we factored it, right? And we factored it by saying, what can I divide out of both the 21 and the 70? Remember, it was a 7, right? So I turn it into 7 times 3n plus 10d. This is the same kind of thing. I can divide both the top and the bottom of this fraction by 7. And if I do that on both the top and the bottom, the exact same number, then I reduce the fraction. And so 21 divided by 7 is 3. 70 divided by 7 is 10. And so our final answer then is 3/10. That is the reduced fraction. It's the same idea as factoring. The difference is that when we factor, we still have that number that we pulled out front. But when we actually are reducing a fraction, we're basically canceling that number out of both the top and the bottom. And so we actually divide it out. And so that number we divided by is no longer present. All right, so here's the answer we get for those first 3 at least. Now for the last one though. For the last one, there is a number that I can divide out of top and bottom straight away and get straight to the reduced answer. It's a fairly large number, and you might not have seen it that way right at the start. Some of you just said, okay, well, I can divide them both by 4, and that was all you saw. That will still work, but I want to show you what the work would look like in case you're using that, because we can go bigger than 4. 32 divided by 4 is 8. 64 divided by 4 ends up being 16. I look at my answer there and I'm like, wait, I can still divide both numbers by something. In fact, I can divide them both by 8. So then I'd do that. I'd say, okay, divide by 8 and divide by 8. And so you notice then we get our final answer, which is 1/2. And now you could have gone straight there, of course. You could have divided top and bottom there by 32, if you happen to see it. But if you didn't see that you could divide top and bottom by 32, go ahead and divide by what you can do. And then just look to see, can you go any further from there? Then just a couple more practice problems doing the reducing fractions, because these can sometimes bring up other questions. So go ahead and reduce these two, please. They're kind of special cases, potentially. All right, so for these two now, the first fraction, what can I divide out of both top and bottom?
6.
6. Now when we do that here, the problem that sometimes this brings up is on the top, what is going to be left? Because some people will look at that and say, but I just got rid of all the 6's. What's left? Well, remember that anything divided by itself is 1. So 6 divided by 6 will be 1, so it's just 1/4. All right, for the second one, something similar happens there because I can divide both top and bottom of that one by 10. So I end up getting 4/1, but I don't really want to leave that as my final answer. Because anything over 1, yeah, is just itself. So that's what I want as your final answer there. It's just 4. So part of the simplifying is that if you end up with something over 1, it just equals that number on the top. Then since we can reduce, we can then combine that with the multiplying that we practiced earlier this year. We'll do one practice like that right now. So go ahead and multiply these and reduce your answer. All right, so when multiplying fractions, hopefully you remember to multiply them, we multiply straight across the top and straight across the bottom. And so in this case, when I just do the multiplication, I end up with 40/60.
Or 2/3.
Okay, now we got to reduce. All right, now when reducing this, most people will do this in 2 steps. So like as I look at this, the fact they both end in 0, well that tells me really quickly that I can divide both top and bottom by 10. So that would give you 4/6, but notice 4/6 can still be reduced even more because both of them are even. And anytime they're even, I can divide them both by 2. And so you end up getting a final answer then of 2/3. And yes, that is what we're looking for as a final answer there. So from now on, any time you see a fraction, if you can reduce it, you need to reduce it. And yes, some of you might have seen that at this step, you could have just divided top and bottom by 20. That's a great way to do it. All right, now where we're going with this today is we're going to be throwing variables in the whole deal as well. So we're going to reduce these fractions. And again with these, you'll notice that they kind of bring us back to the factoring work we did at the start of class. I mean, it's kind of like I have 12x plus 16, and I'm having to factor that. And so it's the same idea. What can I divide both of them by? In fact, you did that problem earlier in class. What did we divide both the 12x and the 16 by? 4. Because when we did it that way, we got 4 times 3x plus 4. It's the same idea here with reducing the fraction. And so I do the same kind of thing where I'm going to divide top and bottom by the same thing. In this case, I'm dividing top and bottom by 4. And so if we do that then, I get a 3x over 4. Notice it's the exact same idea as factoring, except that the thing that I'm dividing out, since it's on both the top and bottom of a fraction, I can cancel it. Same kind of thing for the second one. So for the second fraction, what can I divide out of both the top and the bottom? 5, absolutely. And so I'm going to divide top and bottom of this fraction by 5. Now when I do that, on the top, of course, that becomes a 6. On the bottom, what is 5x divided by 5? It's x. Yep. You could have also thought 1x, but of course 1x equals x. Notice that if I have 6 over x, that is now my final answer. This is not like 6 over 1, which just becomes 6. It's 6 over 1x. And because that's an x in the bottom, it has to stay an x in the bottom of the fraction. So that is your final answer, 6 over x. Anytime you have that variable in there, the variable is basically going to be hanging out in there as we go. Now, these that have the variables in there, you notice it really is a lot like factoring. And we're going to extend that into even something that looks as complicated as this to factor. So, first we practice the factoring side, so please write down and factor this problem. All right, so I look at this and I say, okay, out of all 4 terms, what can I divide out? Well, first of all, notice, yeah, there's x's throughout those 3 terms, but there's no x here. So I can't pull out any x's. So that's why I'm just looking at the numbers here. And out of the numbers, looks like I can divide them all by 5. And so if I can divide them all by 5, that means I got a 5 outside of the parentheses. And then we actually do the dividing by 5. So you end up with, on the inside here, 9x cubed plus 7x squared plus 3x minus 10. And we're done. That is your factored form. If you can do that problem, you can do this one. Because it's the same idea when we reduce a fraction. I am looking to see what can I divide out of every single term on both the top and the bottom. It's just now you have multiple terms in the top or multiple terms in the bottom like this. So again, I'm looking to see what can I divide out of every single term. And so it's the same idea as the factoring. In fact, we have the same setup and the same numbers in there. So I can still divide them all by 5. So that's what I'm going to do. I'm going to divide everything on top and bottom by 5. So when we do that, 9x cubed plus 7x squared over 3x minus 10. And that's it. Now, you might be wondering, what about the 5? Well, I could rewrite this whole thing as 5 times the parentheses and 5 times the parentheses like that. That would equal the same thing, but basically what I'm doing when I reduce the fraction is I'm actually canceling out those 5s. So in this case, when I look at all 4 terms, again I have to look at all 4 of them, I can divide everything on top and bottom by 3. And so that's what I end up doing. So that gives me 6x minus 11 over, now this is the part that can be tricky if we aren't really careful, 5x minus 1. Make sure you have that minus 1 in there because 3 divided by 3 is 1. When factoring, that's the single biggest mistake I see people make is we forget to write the 1 in. The same thing can happen when reducing the fraction, so you got to be aware of it. But if you remembered that rule and learned that rule and had it down when factoring, you have it down for reducing as well. That's your final answer right there. That's all looking good. All right, so when reducing this one, again, we got to look and see what can I divide out of every term. Now, it can be tempting in this case to think 12, because you can pull a 12 out of the top, but not out of everything on the bottom, because I can't pull that 12 out of the 8. Little side note here, you notice there's no x's here. That's why we also can't pull out any x's. Later on, we will actually see this where we can cancel out x's as well. But we aren't quite there yet. We'll just focus on the numbers. All right, so then what can I divide out of all of them? Well, there's only so many things that go into 8. It's got to be a 4, yes. And so I'm going to divide every single term by 4, which gives us 6x squared minus 3 all over 9x to the 5th minus 2x cubed. And there's your final answer. So this is the last problem, just practicing all the things we've been doing. It brings all those skills together we've been playing with. Now, first thing we need to do is we got to multiply them, right? Multiply straight across the top, straight across the bottom. That's kind of like multiplying with parentheses around those. So that 5 is going to multiply by the x and by the 7. So we're going to end up with 5x minus 35 on the top. And on the bottom, that 10 ends up multiplying by both the x and the 8. And so we end up with 10x plus 80 on the bottom. And then reduce from there. And then from here, we look to see what we can divide everything by on the top and the bottom. And in this case, I can divide them all by 5. So I divide everything on the top by 5. That gives me x minus 7 and I divide everything on the bottom by 5, that gives me 2x plus 16. Nothing else comes out of every term. We're done. That's your final answer.